Hello, in this short video, we are going to talk about some cases where the algorithm k nearest neighbors might not perform so well. From the previous lessons, we have learned that in KNN or k nearest neighbors algorithm, since we calculate the distances between a test point and each training data, we can say that all features are equally important. However, in a decision tree, we get the scores of these features to find the most useful feature for our classification. And even so, down the line, as we progress through the tree, some features are just neglected. So it's important to have in mind that in KNN, all features are equally important. And because of this aspect of inductive bias that we see in KNN, the algorithm is likely to do poorly if you have data with few relevant features or few useful features. And uh, instead of having those useful features, we have lots of irrelevant features. And if we have that kind of data, then yeah, our KNN classifier will likely to do poorly. Another aspect where a KNN might not perform so well is varying the feature scale. So varying the feature scale in a KNN classifier will introduce some form of bias that will actually affect its performance. And to demonstrate that, let's take a look at some scenario. So, say for example, we have, or our problem is to categorize or classify whether an object is a ski. Let me draw it more properly. So whether it's a ski or a snowboard. Let me draw it again. So like that. So a ski is longer. I mean, the height is longer than a snowboard's length, but the snowboard's width is wider than the ski's width. And as a standard, the dimensions are measured for height. It is measured in centimeters, and the width is measured in millimeters. If you're going to plot, let's say we have some training data, we have some measurements of skis and snowboards, and let's try to plot them. So for example, here's our table. So we have here our height, and we have here our width. So yeah, so this is in centimeters, and then this one is in millimeters. So in plotting our data, let's use a positive as a representation of a ski, and a negative to represent a snowboard. So since snowboards has wider widths compared to skis, but they are shorter in height, we would expect to see skis around this area here, right? And for skis, we would expect to see them around here because they have longer heights but shorter, or I mean, yeah, shorter widths compared to snowboard or slimmer widths. So you'd expect to see this kind of plots. Now, to demonstrate the effects of varying the feature scale to the performance of a KNN classifier, what if instead of using millimeters in measuring the width, we try to use centimeters? So if we're going to plot that again, here's our table or graph. So the height is still the same, it still uses centimeters, but now the width is in centimeters. Now, since the width is a lot smaller, the values of the width now in centimeters are now a lot smaller compared to the values of the height, we would see, or we would expect, that the snowboards, since the values of the width are now really small, we would expect to see the snowboards to be in this space or area. And the same thing with the skis, we would see them around here because they have longer heights. Now, what happened here is that since the values of the widths are a lot smaller compared to the height, the KNN classifier now would effectively just base its predictions almost purely on height and will just neglect the width. And yeah, that's how varying the feature scale in a KNN classifier affects its performance. So that's it for now. With regards to feature scale, there's a lot more about this topic, but we are going to have another lesson for that will allow us to dig about feature scale. But for now, knowing the basic concept about what feature scale is and how it affects the classification of a KNN algorithm would be enough. And until next time.